So I'm going to present our paper about differential privacy by design, um, which is especially about the COVID-19 data privacy and how to use it for a collaborative kind of research in contemporary age. So the outline is like we can discuss about the privacy challenges which we are facing today, and then some idea about the privacy by design and how it is embedded into machine learning systems being used today. What are the limitations? Why it's not addressing all of the concerns of privacy in current machine learning systems, and how it can be made better and simplified. So this paper comes up with the idea of a differential privacy by design framework, which is a theoretical framework which try to figure out and simplify most of the complications around this area. And then we suggest the 7 principles of design, how the differential privacy can be embedded into machine learning systems. Well, we all are aware like the data privacy is a big concern because we have all the digital data and assets can be shared today, and and we are living in a connected world, and this connectivity offers us a great risk as well. So to address this risk, many different countries and continents have come up with their own regulations. One of them is known as GDPR, which is General Data Protection Regulations by European Union. It restricts the data movement and the data transfer across the borders of European Union. And similarly, other regulations exist in other parts of the world. So the point is, while we are facing the calamity, are facing the disaster because of the COVID-19 today, many different researchers want to work together collaboratively across different disciplines. And they want especially, and this whole research depends on the data. And if the data cannot be shared between the teams, then how it's possible to work on these collaborative projects? So is there any solution? Well, so it came up with the background of the privacy by design framework, which became a part of the regulations as well, because the privacy shouldn't be separate from the design. It should be embedded into design from beginning to end. So this is a very powerful concept. Because, however, it's criticized because it's unclear, it's complex, and it's very difficult to enforce privacy by design. And the case study which we have discussed in this paper is machine learning systems. The machine learning systems are part of the artificial intelligence systems which try to learn from the data and try to give an inference about the data, maybe a classification, a regression, or something like this. So they are heavily used in healthcare systems, and they are very relevant in today's environment when we are trying to fight the COVID-19 disease-related research. However, the machine learning systems heavily depend on data. And if we have problem with data sharing and data privacy, so it means like the machine learning system will not be safe. Google came up with a revolutionary concept which is like how to embed security into machine learning, and that's known as federated machine learning systems. The idea is a bit simple because it's a kind of distributed system where different clients are trying to interact with a centralized system. In a traditional machine learning system, we share the data with the central server, and the central server try to develop a model, and then that model can take decisions. But in what is different in federated learning is like you may have individual clients, but those clients will not share the data. Every client will train their own model and they will share only the model, not the data. And in this way, the privacy is embedded. One good example is the scenario of COVID-19. Many different teams across the borders are working at different problems related to COVID-19 data. So if they are essentially working on machine learning systems, so what they can do is like they develop their own model and they share the model with a federated server. And the federated server has some federation technique like federated averaging or other similar kind of robust technique which take an average of all those models, create a new centralized model, and that centralized model is again shared with each client and they can use it for inference. Now at any point of this learning, data is never shared, and that's what the beauty of federated learning is. However, this system is not that secure in a way like during the communication, if any attacker try to get access to the model which we are trying to share, there is a possibility that they try to get some insight about the data which is being used for that model. Now, how can we take care of the data or the models during the this federated learning process? So one possibility is to use differential privacy, which try to use some sort of a noise or try to give some quantification of the privacy, like how much, what loss of privacy we can afford. And in this way, the system can be secure because there's a noise in the model. So that will become very difficult for the attackers to find the model. However, it's not that simple. There are many different complications. Like if we add to, how much noise should be added to the model? That's a problem. Okay, so these complications around the differential privacy, which is a separate discipline, and the federated learning, which is a separate discipline, and their embedding becomes very complex. So in this paper, we try to simplify this marriage and we say, what are the most important parameters which must be taken care during the design of such a system? So we came up 4 different quadrants, which point to the privacy versus utility and the scalability versus robustness. So the idea is like we came up with the quantification of privacy, some privacy budget, how much privacy budget should be allowed. So there should be some empirical value in the design, like, so how much privacy loss can be afforded. Similarly, the noise, how much noise would be added to the model to make it robust, but in such a way like it's still usable, its utility is not compromised. Then the global sensitivity is like when we have a centralized model, so that aggregation must be insensitive to the changes to the individual client level. So it shouldn't be possible from an aggregated model to do the reverse engineering and find out the individual model. And the 4th factor is the number of clients, like whatever the system would be developed by this way is like it should be designed in such a way like if we keep on adding number of clients, the scale, like it's scalable and the privacy is not compromised by this process, and also not the accuracy of the system. So these 4 quadrants are very important. These 4 parameters which are based on these junctions, they are also very important. Based on that, we came up with 4 different principles which can guide for a better privacy by design framework. And these 7 principles are like this, like the privacy can be guaranteed in the design. When we design federated machine learning systems, there should be some guarantee about the privacy. There should be some assurance, and that assurance should be quantified. Like there should be some empirical value for privacy budget. We try to divide the system into different modules and try to embed privacy into a modular approach rather than an overall approach. So in this way, it can be simplified. The privacy can be embedded into federated design. The federated design is the aggregated model, so that if the aggregation model is not robust um, for privacy, then the individual models can be extracted from it, and then the privacy can be compromised. So in that way, the federated averaging method or federated method must be robust enough so that the privacy embedded at that level. Scalability aspect must be considered, like when the number of clients are reduced or they are increased, it will not affect the privacy. And the anonymity in the design lifecycle means like the original data will never be shared. It will always remain private. Only the models will be shared. There is always, and the 7th principle is like there is a trade-off between utility and privacy. More private systems are less utilized, and similarly, if you make it very, very accessible systems, they will be less private. So there should be a compromise between the two. There should be some sort of optimization between the two. So the design consideration must consider this factor. So overall, in this paper, we came up with a theoretical contribution in a way, like we came up with a framework that simplifies the way data can be like data can be shared in a collaborative manner without compromising its privacy. So this framework fills up all the gaps because it tried to simplify and try to find out all the most important parameters that are required um, for designing a federated machine learning system. Thank you very much. Now, if you have any question, please put it on a discussion forum, and we will try to engage ourselves in the discussion. Thank you.